So for today, if sines like y and cosines like x, that's why x squared plus y squared is equal to r squared in a circle. And this would also work for the Pythagorean. So you got that. Then I told you to memorize this one and this one. One with the tan is what you seek. One with the coat is cozy. These are the reciprocal ones, like cosine and cosecant. They're sister functions. You know, they're the flip of each other. And here's the ratio ones. Tangent is sine over cosine. Cotangent is cosine over sine. I want to talk about these today. So to do it, I want you to make me quadrant 1, a 30, 60, 90. 1, 2, square root of 3. And I'd like you to figure out what sine of 30 is. It's not real hard, but once you get the triangle drawn, we can do a lot more. Okay, if I asked you what sine of 30 was, this would be like the 5th time I've asked you what sine of 30 is. It's opposite over hypotenuse, so you should have said 1/2. Raise your hand if you had a half. Okay, awesome. Well, what's sine of negative 30? Draw it. It's really nearby. Sine of negative 30. Well, that's down here, isn't it? It's 30 degrees in that direction. And this is still 1, 2, and this side's still square root of 3 over there. But one of them's negative now. But will it affect sine? Oh, yes, it will. So sine of negative 30 is the opposite of hypotenuse. It's negative 1/2. Do you get it? It was pretty darn close to 1/2. It was just negative of it. So that's what this means. Sine of the opposite of the angle is the opposite of the answer we got for regular sine. Now, I could go through and do examples of every single one of these, but I'm not going to. This is just why these are true statements. Tangent works the same way as sine does. If you take tangent of the opposite of an angle, then it'll be the opposite answer. Let's do that back over here. Let's look at tangent of this. Would you agree that tangent is TOA, opposite, over, adjacent, and therefore 1 over square root of 3? And if I go down and do tangent of negative 30, look, I get negative 1 over root 3. It's the same answer except negative. So, see, if you do it for tangent, it's the same as sine. Cosine's the only one that's different. And that's because if you go down and you do cosine of this, look what happens. Cosine is adjacent over hypotenuse, root 3 over 2. And then if I do cosine of the negative angle, it's still adjacent over hypotenuse, and those numbers are, neither one of them are negative, so it stays the same. Isn't that weird? You can do cosine of negative of the angle, and you can still get the same answer. All right, so I'm just explaining why these are true. And then why are these true? Because they're just a flip. You know, cosecant is just 1 over that. And if you do 1 over something, are you changing the sign of it when you put 1 over something? Do you change the sign? If I put 1 over 1/3, did it turn negative? No. So when you put 1 over something, which is all these are 1 over the other one, all of the signs, you know, the negativeness of the angle and the answer, they don't change. So that's why those all work. So then if you're in the middle of a proof and you see this on the test, secant of negative x, what could you replace it with? It's the same exact thing as secant of x. Why? Because this says so right here. You get that? If you saw secant of negative x, you could replace it with just secant. And you don't have this anymore, and you just replace it with that. Okay. All right, there's another set I want to explain to you, and these are the cofunctions. I really wish they would have done this one in degrees, because I think it really helps you understand this a lot more if you do it in degrees. But everybody write sine of 30. Did anybody ever notice that that was the same as the cosine of 60? You notice that? Kept coming up. And it's like, if you got 1/2 and then you go do cosine of the other angle, you also get a half. Huh. Did you know that it also works, though, if I had, like, sine of 10 degrees? That would be exact same thing as cosine of something. If you see sine of 10 degrees in a problem, you can replace it with the cosine of 80. Very good. Because those two angles add up to 90. This is the math way of explaining, here's two angles that add up to 90. There's the angle, and then there's 90 minus the angle. That's what that means. The two pink things I just circled mean 90 minus the angle, because pi over 2 is like 90, right? 90 minus the angle and the angle. So if I have an angle of, let's say, 30, then this would be 90 minus 30, and that'd be like 60. So this and this add up to 90. They're saying if you have tangent of, let's say, 12 degrees, you could just as well replace that with cotangent of something that adds up to 90 with it. I think it's 78. Isn't that right? So cotangent of 78 and tangent of 12 are exactly the same. These are called co-functions. So what's the co-one for secant? Cosecant. See? So if I give you secant of 75 degrees, that's just exactly the same as if I did cosecant of not 75 anymore. What? 15. Yeah, but who on earth is going to know what cosecant of 15 is? Well, I wouldn't do cosecant. What would I do? Remember how you don't do the you don't do the weird ones? You'd switch it to sine. Yeah, you'd figure out the sine of 15 degrees and then you'd flip it. Right? Remember what I'm talking about? When we did it this kind, the newer function, we did sine, cosine, and tangent for so long that if you ever got the cosecant question, you just change it to a sine question and then flip it. Okay, so then really this question becomes sine of 15. And that brings me to these, the sum and difference identities. So if I wanted sine of 15, nowhere on the sum and difference identities would you find sine of 15. But do you get that I could change this sine of 15 degrees into sine of 45 minus 30? Do you agree 45 minus 30 is 15, right? And nobody in here knows what sine of 15 is. There's no reason you would ever know that. Nobody memorizes that. But that's the same exact thing as sine of 45 minus 30. Now, this is important. You might think, oh, I can just find sine of 45 and then the sine of 30 and subtract them. No, it doesn't work like that. This is not like a distributive thing. To find sine of 45 minus 30, you got to follow these little rules that they've given us. Which of these is a subtract? Only one of them is the one I want. Do you see which one? Second one down, yep. I want the one with sine and a minus in there. It's this one. So you got to do sine of the first angle times cosine of the second angle minus cosine of the first angle, sine of the second angle. Holy crap. But yeah, that's what you have to do. And we're going to do that right now. We're going to figure out the sine of 15 degrees without a calculator. All right. So I would like you now to go onto a separate document. Get a new, clean document up. And I would like you to have these side by side so that you can see them, so that you have a blank piece of paper. I don't want you just writing on your sheet the whole time. So get a blank piece of paper and then everybody start by giving yourself one nice example. There's two kinds of problems for today. I want you to leave here with two really good examples of two types of questions you'll have to know on the test, which is coming when? Thursday. Today's everything except double angles. Tomorrow is double angles. That's like sine of 2 theta, okay? And then Wednesday's a review, and then Thursday's the test. All right, so here's the 2 types of questions you have to know for today. The first kind, if I ask you for the sine of 15, you right away go, oh, you must be doing one of these kind where I can break that into sine of 45 minus 30, because I know both of those. Oh, by the way, just side note, could I have also done sine of 60 minus 45? Wouldn't that also have been 15? Yeah, I'm not going to do that, but you could have, and it would have worked. We're just going to do this first one. And we need this highlighted one right here. So you can copy it off of mine, or you can have it split screened on your screen. And now you do sine x, but let's not say x. In our case, we know x. This is like x, and this is like y. So sine x is really sine 45. Now, don't try to go figure it out yet, because there's too much left to do. Next, we're going to do cosine of 30, which is something we can do later. Minus, see that minus right there? Minus cosine of the first angle, which was 45, which is something I can do. And last is sine of which one? 30. Please tell me that some of you have got one of these memorized and you can just tell me what it is. Yes? Sine of 30 is a half. See, if you have to waste your time doing that, he doesn't. I don't either, because I memorized that one. Okay. What was that cofunction deal? That would also meant that cosine of 60 would have been a half. Now, we don't happen to have that one. But okay. Then I'm going to go and I'm going to figure out each of these. How? Well, you can draw 30, 60, 90, and 45, 45, 90s, can't you? Take a minute and fill in those 3 empty spots. Sine 45, cosine 30, cosine 45, sine 30. You'll automatically get it all set up nicely to have common denominators. They're already common. It's awesome. It works out nice. The denominators will be common denominators if you do it right. And then you'll take the one fraction minus the other fraction, and since they have common denominators, it works out super well. All right. This is the part where you're going to need a partner to make sure you are doing this right. So I want these 2 rows 1 and 2. Okay, let's see here how you did. Sine of 45. Sylvia, what'd you guys get for sine of 45? All right, sine is opposite over hypotenuse. And so 1 over root 2 would have been better, actually. I know some of you were thinking, oh, I'll be fancy and do the deal where you rationalize it. But the problem is, then you aren't going to have a common denominator with the other side. So trust me, just leave it that way. And now cosine of 30. Henry Good, what'd you just get for cosine of 30?
Sorry.
Here's the 30.
Square root of 3 over 2.
Yep. And now look how my denominator is developing to be 2 root 2. Now go over to cosine of 45. Graham Tyler, what'd you get for cosine of 45?
1 over root 2.
1 over root 2. Now, if you did rationalize both of them, you did a lot of extra work, but I guess it does look like you would have had a common denominator. But these would have had a perfectly good common denominator in the first place. And it's square root of 3 minus 1 over 2 root 2. That's just me subtracting the top. And the bottom is 2 root 2. And there it is. Raise your hand if you had that one right. Okay, cool. So let's just do one more of those so it sets in stone for you of how to do this. Was there any part of that you want me explained? Like, I don't get where you got this. Don't be shy. Be brave. Yes? You're going to leave it just like that. The only thing would be rationalizing, and how many times have I said this? I'll say it again. Can you rationalize?
Yeah.
Yes. Do you have to rationalize?
No.
No. Yep.
With root 6 minus root 2 over 4, it'd be fine.
I don't know. What did you do?
Well, we rationalize.
Oh, are you allowed to rationalize? We just talked about that. Yes, you can rationalize if you want to.
Like, is it fine to have the 2 roots on the numerator like that?
It's okay to have roots in the numerator, yes. All right, so I'm not going to talk through ways to rationalize because I think it's kind of dumb. It's extra work, and your teachers next year, the reason I think that is because your teachers next year are going to tell you, don't rationalize, because it's a chance to screw up. And the answer would have been fine without rationalizing, and it's a chance to mess something up. So don't do it. Because if you rationalize wrong, you will get it marked wrong. You can have the right answer on your page, and if you keep going and rationalize it and then screw up the rationalizing, now you lose the point. Okay, so that's why I'm being kind of harsh on the rationalizing, is because I was taught to tell you not to rationalize, but is it allowed? Okay, yeah, it's not wrong. It's just extra work that you might mess up. All right, so let's do one more like that. Let's try cosine of, now I know I want it to be something that you could, well, maybe like add together, you know, because we just did a minus one. So how about if I say 60 and 30, which would be 90? No, that'd be too weird, because if I say cosine of 90, you're just going to go, oh, I can find that one with the unit circle. You know what I mean? So I'm not going to do that one. But what would be one that you couldn't normally figure out, but you could figure out with this? Cosine of 75. Without any calculator, as long as you knew these sum and difference identities, you're going to change this to cosine of something plus something. And you'll know the two somethings. And then you'll look it up on the sheet and you'll go, oh, I see that one, cosine of x plus y. And then you write it all out and see if you can do it with your partner. You might need some help. So usually by now, kids have got the two numbers. What do you think I'm doing? What plus what? 45 and 30 totally works, but there's another way. Could have been a 60 and a 15, but the 15 would have been a pain in the butt because you'd had to go off and do something else with that. So this is probably the best way to do it. I mean, for sure. All right, so then you got to go look it up on the sheet. Write it all the way out. And it's cosine minus sine. This is the way I'd do it. I'd write out the cosines and sines, and then I'd go back and put in the angles. All right, I'm going to pause for a minute while you guys try this. Okay, cosine 45, cosine 30, sine 45, sine 30. And I know sine 30 because I have it memorized. Do you? I didn't have to look that one up. It's a half. Okay, I have to look up sine 45 though, so 1 square root of 2 won't take long. Opposite over hypotenuse, 1 over root 2. Cosine of 30, it's the same as sine of 60 if I wanted to do it that way, because you learned about cofunctions. But that's 30 and 60 and... Oh, wait. That's 30, 61. 2 square root of 3. Cosine is adjacent over hypotenuse, root 3 over 2. Cosine of 45 is 1 over root 2. Root 3 minus 1 over 2 root 2. Looks very similar to the last one we did. Raise your hand if you had that one right. Cool. That one's not too hard. Now, there's another type of problem that I got to get you ready for, and it's definitely harder. Ready? Write this one down. Sine of alpha minus beta. Well, that's a big clue that they want you to do that formula that you have on the sheet. So, everybody write out that formula that you have on the sheet, except throw in alphas and betas. Now, of course, it'd be nice if it was that simple. You can't just copy down that formula off a sheet and be done with a hard honors pre-calc question. So then, this is the part where headphones need to come out and cell phones need to go away. Okay, so now I got to tell you more about alpha and beta. But I'm not going to be quite as obvious as last time where I just said it was like 45 and 30. This time I'm going to say that you can figure out alpha by this. I'm going to make one of these weird and then one of these kind of normal. Sine of alpha is 1/9. Thank you. Sine of alpha is 1/9. So then now I can, wait a minute. Did that allow me to figure out what alpha is? No, but I don't really need alpha. I really need, I'm going to go look it off my sheet. Sine of alpha minus beta is sine cosine minus cosine sine. Sine alpha, beta, alpha, beta. So I don't really need the angle because you'll never figure out this angle. I mean, you could if you had a calculator, but we don't need the angle. We need sine of the angle. Well, I already have that. It says right there, sine of the angle is 1/9. Done. Cool. But then I'm going to have to get cosine of the angle. And to do that, that means that this question, which is just like one of the ones on the chapter 12 test, remember me telling you that chapter 12 would keep coming back over and over? Here's one of those moments. To get this one, I got to draw my triangle, and I got to figure out, oh, by the way, I got to tell you this, and I didn't. I'm going to say in quadrant 1, because there is 2 places this could have been. So I should have said in quadrant 1, you can draw your triangle, you can figure out the opposite and the hypotenuse and then the other side, and then you'll be able to figure out cosine of the angle. All right, so there's my hint on what alpha is. Here's my hint, I'll do it in green for beta. Beta is given to you by knowing that tangent of beta is -1 in quadrant 2. Now, did I tell you what beta was? No, but you could figure it out now by drawing a picture again. So your alpha picture, I've done a lot of these. Trust me, this is a good idea. That's my alpha picture. That reminds me that those are my angles I'll use alpha for. Like when I want cosine of alpha or sine of alpha. And then this is my beta drawing in quadrant 2. So label this the beta drawing. It's like a bee with a long tail. All right, so your job is to figure out sine of alpha minus beta. You'll use this thing off the sheet right here, and then you'll replace these 3 parentheses with sine of beta and cosine of alpha and cosine of beta. And this one was given to you right off the bat. So I didn't have to work hard at it. I just had to know what they told me. All right, the rest of it, it'll work out of the perfect common denominator again, which is pretty cool. And some of you are probably already done. I'll pause for a minute while you work this one out. So let's finish this off, and then we'll talk more about when you'd ever use this. So the 1/9 here was given to us, so that one was easy. The cosine of beta, well, to get beta, I got to go in here. So how do I get those? That came from this fact. And so since tangent was -1, that's TOA, opposite over adjacent, and then this is square root of 2. And then that is tangent of beta. So what did I really want, though? I wanted cosine of beta and sine of beta. Well, cosine of beta, oh, wait, forgot, that's negative and this is positive. I had the wrong one being negative, my bad. Wait a minute. Hold on. TOA. Yeah, only one of the 2 needed to be negative, and it was the bottom one, not the top one. That's all. Okay, so now I want cosine of beta So that's adjacent over hypotenuse, so negative 1 over root 2. And then I want sine of beta for this last spot here, and that's 1 over root 2. And then I want cosine of alpha, and that's up here. Well, to get that one, I have to do sine is opposite over hypotenuse, and this is the square root of 81 minus 1. You square both of them, you know. And then this is not the longest side, so you subtract. So it'd be 81 minus 1, so square root of 80. Should I simplify it? Yes. I think 4 goes into that, and therefore it'd be 2 root 5, is it then? 4 square root 5. I'm hearing. Did anybody else simplify it to that? Okay, yay. All right, so this one's 4 square root 5. Then I'm going to go and get cosine of that angle, which is adjacent, that one, over hypotenuse. So 4 root 5 over 9. And once again, magically, I've got a common denominator. 9 root 2 and 9 root 2. That worked out pretty cool. So the answer has a 9 root 2 denominator. And on top, I have 1 times negative 1 is negative 1 minus 4 root 5 times 1 is 4 root 5. And there is a really complicated math question. Now the cool thing, if you just want to why would you need this? If you needed to find the, could you shut the door back there, Campbell, please? Thank you. If you wanted to find the sine, cosine, or tangent of a lot, this opens it up to a lot of things. You could find like the tangent of 15 now without a calculator, because you could just make it into a 60 minus 45. In fact, that's how I want you to end, and this is probably our last problem that we have to do together, is everybody, if you just need to figure this out without a calculator now, you can do it. Now, granted, this one, you don't probably have the formulas memorized, so, but that's a scenario where I could see the ACT, for example, saying, given the tangent of x minus y is, and I'm just reading to you right off the sheet, tan x minus tan y over 1 plus tan x tan y. I just copy it off the sheet. Given that, figure out tangent of 15. This would be absolutely in the top 10 hardest questions on the ACT, but you could do it. So we've already got this. Now we just got to know what x and y are. And you already have done this. We did one just like it a few minutes ago. Have you figured out what the tangent subtract should be? You going to do 30 minus 15 to get 15? No, that doesn't make any sense. About 60 minus 45. That's the same as 15, isn't it? Okay, and that one's actually a little too easy. Honestly, it's a little too easy. So from here, I'm going to just give you a minute to finish it, but then we'll make it a little more like an honors pre-calc test, because this one's a little too easy for one of the hardest questions that I'm trying to lead up to. 1 root 2. With those two little triangles, you should quickly be able to tell what tangent x, tangent y are, and you can fill this out and you'll be done. I'll pause for a second while you finish that. Okay, so tangent of 60, I'm trying to do this, and then tangent of 45. Well, tangent of 60 is TOA, opposite over adjacent, which is square root of 3, minus tangent of tangent of y, which is tangent of 45, which is TOA, which is opposite over adjacent, which is 1 over root 2. That's the top, over 1 plus, now I got the same exact two things. Tangent x, which is square root of 3, I already did it. Tangent of y, which is 1 over root 2. Did you guys get that? This is tangent of x, right? Square root of 3. Just tangent of 60. All right, now how could this have been harder? What if instead of tangent of 60, just saying it was 60, what if they said it was alpha and beta? So I'm going to give you one last one like that. And then your homework is one of those kinds of questions. So we're going to do those right now. You can start your homework together. You're going to have problems 23, 24, and 25 are the ones I'm assigning. And I'm wrong. It's 20. Double checking this. Yep. Nope. 23, 24, 22, 23, 24, but I don't see problem 22. Where the heck is 20, problem 22?
So the previous page, blue page.
Oh, yeah, I just blew past it. Thank you. Okay. Problem 22. Let's do that one together right now. Okay, so here's problem 22. So this is coming out of today's notes page. At the end of the notes is always where the homework is. It says, if alpha is in Q4, so you and your partner together, draw a Q4 triangle, which should be like here. And this is alpha's drawing. And alpha is technically the angle that goes all the way around to here, but we're just going to use this reference triangle. With cosine of alpha is equal to root 5 over 5. Cosine is adjacent over hypotenuse, root 5 and 5. You should be able to figure out this third side, and you'll need it. So that's how the problem starts. And that's all about alpha. Now you separately go and draw a separate drawing for beta. This was the alpha drawing. Here's our beta drawing. For beta, it says sine of beta is root 10 over 10. Now it doesn't say that it's in quadrant 4, and it can't be actually. Oh, it says where pi over 2 is less than beta is less than pi. So what they're trying to say is that you're in between pi over 2 and pi. That's just a fancy way of saying your triangle's in there. And now it says sine of this beta is root 10 over 10. So then sine is opposite over hypotenuse. So from this angle's perspective, it's opposite over hypotenuse of 10. And you'll figure out this third angle here, really important. And then whenever you want to finish this question, you know what? It's number 22 is so intense that I think just doing part A would be plenty. So please, everybody go to problem 22, part B, and just cross it off. All I'm going to ask you to do is find what's cosine of alpha plus beta. And with these drawings done already, it should be easy for you and your partner to finish this off. The first thing you got to do, though, is look on the sheet, because nobody has this memorized. Cosine of alpha plus beta, not nobody in the world, but nobody in this room. Cosine of something plus something. It's right off the sheet. It starts with cosine, minus. Very good. And you can get those from the triangles. It all comes back to drawing the triangles, and that was all about chapter 12. That's why I was saying you really needed to focus on chapter 12. So that's the start of your homework. And that's all I got for you for today.